In this lecture, we see Maclaurin's theorem, and using the Maclaurin's theorem, we are able to get some standard expansions. So here we only take what are the that expansions which can be write down in terms of the formula. Let us first see what is the Maclaurin's theorem. Let f of x be a function of x differentiable n times. Then Maclaurin's series of f of x is given by f of x equal to f of 0 plus x into f dash of 0 plus x square upon 2 factorial into f double dash of 0 plus x cube upon 3 factorial into f triple dash of 0 and so on. So this is called Maclaurin's theorem, and it is, since we are giving this theorem in terms of series, so this is called Maclaurin series. And most of the functions for which f of 0 is not 0 or f dash of 0 is not 0 or not defined, then are defined, then we are able to find out the series expansion of such type of functions. So let us take some standard expansions without proof. First, exponential function of x, which is equal to 1 plus x square upon 2 factorial plus x cube upon 3 factorial plus x to the power 4 upon 4 factorial and so on. It can be written as summation of n equal to 0 to infinity of x to the power n upon n factorial. Similarly, the expansion of e to the power minus x is equal to 1 minus x plus x square upon 2 factorial minus x cube upon 3 factorial plus x to the power 4 upon 4 factorial and so on. And if we write down in terms of summation, summation of minus 1 to the power n into x to the power n whole divided by n factorial when n is taking from n equal to 0 to n equal to infinity. The third expansion is for sin x, which is equal to x minus x cube upon 3 factorial plus x to the power 5 upon 5 factorial minus x to the power 7 upon 7 factorial and so on. It can be written as sum of minus 1 to the power n plus 1 into x to the power 2n minus 1 upon 2n minus 1 factorial when n is calculated from n equal to 1 to n equal to infinity. Similarly, expansion of cosine x is equal to 1 minus x square upon 2 factorial plus x to the power 4 upon 4 factorial minus x to the power 6 upon 6 factorial and so on. Expansion of sine hyperbolic x, which is equal to x plus x cube upon 3 factorial plus x to the power 5 upon 5 factorial plus x to the power 7 upon 7 factorial and so on. Similarly, expansion of cosine hyperbolic of x is equal to 1 plus x square upon 2 factorial plus x to the power 4 upon 4 factorial plus x to the power 6 upon 6 factorial and so on. So if we see the expansion of sine x and sine hyperbolic x, in sine function we are getting alternate minus plus minus plus plus minus plus minus, but in the expansion of sine hyperbolic x all terms are positive. In a similar manner, if we compare the expansion of cosine x and cosine hyperbolic x, we again look the same thing, that plus minus will come alternatively. So 1 minus here 1 plus. So 1 minus x square upon 2 factorial, 1 plus x square upon 2 factorial, plus x to the power 4 upon. So all negative term, this negative term will become in positive term. So expansion of cosine hyperbolic x and sine hyperbolic x can be directly obtained with the help of expansion of sine x and cos x for ready reference. Now let us take one more example. What is the expansion of 10x? So expansion of 10x is x plus x cube upon 3 plus 2x to the power 5 upon 15 plus 17 upon 315 into x to the power 7. Expansion of 10 hyperbolic of x is x minus x cube upon 3 plus 2x to the power 5 upon 15 minus 17 x to the power 7 upon 315. So if we see the expansion of 10x and 10 hyperbolic of x, we are only uh, giving the differences. There are plus minus will come alternatively in case of 10 hyperbolic h. but all term will be positive if we want to expand tan hyperbolic of x. Next, what is the expansion of sine inverse of x? So it is nothing but x plus x cube upon 6 plus 3 upon 40 x to the power 5 and so on. Similarly, if you want to find out the expansion of cosine inverse of x, we have to just subtract by pi by 2. Pi by 2 minus what are the this thing x plus x cube upon 6 plus 3x to the power 5 upon 40. These are the expansion of tan hyperbolic x, tan x, sine hyperbolic sine inverse of x, cos inverse of x, and let us take also the tan inverse of x. It's very simple. What is the derivative of tan inverse of x? It is x minus x cubed by 3 plus x to the power 5 minus x to the power 7 upon 7 and so on. Similarly, we are able to write down what is the series expansion of sine hyperbolic inverse of x is similar, but only the plus minus will come alternatively. In the same case, we are also able to write down cosine hyperbolic inverse of x. Again here, this pi by 2 expansion of cosine inverse of x and cosine hyperbolic of x. What is the difference? Only here all terms are positive, but here the plus minus will come alternatively. Let us take some more example of more formula. Tan hyperbolic inverse of x is nothing but 1 upon 2 log 1 plus x upon 1 minus x, and it can be written as x plus x cube upon 3 plus x to the power 5 upon 5 plus x to the power 7 upon 7 and so on. Expansion of log 1 plus x is x minus x square upon 2 plus x cube upon 3 minus x to the power 4 upon 4 plus x to the power 5 upon 5 and so on. If you want to find out the expansion of log 1 minus x, the all term will become negative. All term will become negative minus x square upon 2 minus x cube upon 3 minus x to the power 4 upon 4 and so on. We know that 1 plus x whole to the power n, it is a binomial expansion. It can be written as 1 plus nx plus n into n minus 1 upon 2 factorial into x square plus n into n minus 1 into n minus 2 upon 3 factorial into x to the power 3 and so on. If we write down, if we substitute n is equal to minus 1, then we are getting very interesting things, which is 1 minus x plus x square minus x cube and so on. If we write down the expression for 1 minus x is 1 minus x to the power minus 1, here all term will become positive as comparing to 1 plus x to the power minus 1. Here alternatively plus minus will come, but if we write down both are negative, 1 minus x to the power minus 1, then all term will become positive. And if you write down the expansion of x plus a to the power n, we use the binomial expansion, and also we know that what is the binomial expansion. So these are some standard formula for expansions of functions using Maclaurin series. Thank you.